Hey everyone, so this is our next video in chapter 10, which is all about circles. Last section we learned about lines and segments within circles and how they interact and form different angle measures. Now we're going to talk about a completely new idea of an arc and discover angles as well within the circle. So we've got some vocab here to start just like normal. So a central angle is kind of what it sounds like. I want you to really think about that this is called a central angle for a reason, right? This name can really help you understand things a little bit better. So a central angle is an angle whose vertex is the center of the circle. That's what you should be thinking about, that it's the center. So if we look at this picture here, the angle whose center is on whose vertex is on the center, right, is right here. So if we look at that point, I've got angle BAC. Angle BAC is a central angle. We know we could also be angle CAB. And that's our central angle, okay? The vertex, we're interested in this measure right here. The vertex is on the center. Then we've got an arc, a portion of the circumference of the circle. So now we're no longer interested in that center measure. We are interested about the circumference, about the outside of the circle. Think about it like the crust of a pizza. Okay, so a portion, so this is the piece I'd be interested in. CB, arc CB, or maybe arc BDC around the outside. So how do I know which one I'm going to be looking at? Okay, so first of all here, we've got a semicircle is half of a circle, okay? So semicircle is a half of the circle. That should be familiar to us. We use the diameter. Because we know the diameter is going to be cutting the circle right in half. Now let's check out the measure of what we call a major arc. Is larger, right, because it's major, larger than a semicircle. You name a major arc or a semicircle, so this is the same notation for whether it's a major arc or a semicircle. We use 3 letters, and which letters do we use? We use both endpoints and a point between them. Okay, the additional letter, that point between them, helps us determine the direction. Okay, and so what I mean by that is, and let me jump over to the definition of a minor arc. So think about if a major arc is larger than a circle, a minor arc is smaller than a semicircle. We name a minor arc by 2 letters. So just use both endpoints. And so now we can compare what's the difference here and why it's different. So look at this arc right here. BC is the blue crust. That is how I would name that minor arc, BC. And notice I've got a little arc symbol above it. I cannot name that orange arc, BC. I need to name the orange arc BDC. So see how it needs to tell the direction. It needs to have it go this way, or the direction doesn't matter, but it needs to hit through that D point so I know I'm talking about this portion of the circumference instead of the little one. 2 letters, minor arc, 3 letters, major arc, or a semicircle. Ooh. Okay, let's keep going here. And let's practice this example. So let's list some minor arcs of circle A. So I've got PQ. Sorry, guys. This is jumping all over the place. I've got minor arc PQ. I've got minor arc PS. 2 letters, right? Minor arc SR. Minor arc RQ. Do all these make sense? And then I even have minor arc SQ. And notice I still have 2 letters for that because it's a minor arc. 2 letters means it's a minor arc. Okay, let me erase this and let's list the semicircle. What's the semicircle? We will use 3 letters. Here's the diameter. That's going to help me kind of find the semicircle. I can say the semicircle is arc RSP. I can also say it's RQP. Just like color by number, follow those letters, connect the dots, right? RSP sends me this way, RQP sends me this way. Connect the letters. Okay, let's check out the next question. Major arcs containing point Q. Here's point Q. Let's say we've got PSQ. See that? PSQ. We can say RSQ. I'm just going like outside there so we can see it a little bit better. We could say SQR. We can say QRP. And we can say PQS. Okay, major arcs just need to be greater than a semicircle. And then the acute central angles. So now we're focused on the center point and we're looking at central angles. I can say PAQ. Notice how this totally changed how we're looking at this diagram, how we're, interpreting the central angles. We need to be flexible going back and forth between 2 different measurements, arc and angles. So now I have angle SAR is the other one. Okay, let's keep going here. Let's talk about measuring arcs. The measure of a minor arc is equal to the measure of its corresponding central angle. So if I use this example right here, the minor arc RT is 50 degrees because the central angle RST is 50 degrees. The angle is 50, the arc is 50. That's how we measure minor arcs. Major arc is the measure of the related minor arc subtracted from 360. So if I look at the major arc here, that's going to be RQT. RQT, we know it's 360 degrees all the way around a circle, minus 50 degrees. That's going to give me the 310, right? Because this 50 is taken out. And I just want this part of the crust, because this was 50, so we subtracted it. And then we know a semicircle is always 180. Okie dokie. Adjacent arcs is the next vocab word we want to touch on. We are very familiar with this term adjacent. We know that means next to. So we are looking at arcs that are right next to each other. They have exactly 1 point in common. So we can look at an example. Here I can draw you an example. If this is D, E, G, I could say arc DE and EG are adjacent arcs because they have point E in common. They're next to each other. So what's cool about adjacent arcs is that we are going to use them to find the sum of bigger arcs. That's what this arc addition postulate says. The measure of the arc formed by 2 adjacent arcs is the sum of the measures of those 2 arcs. So I can say arc BA plus arc BC equals this entire arc ABC. That's the arc addition postulate. We have to piece all of these crusts together. Problem 2, what is the measure of each arc in circle C? Okay, so PR. Well, the central angle is 77, so I know PR is 77. RS. Once I see RS, I notice I have a diameter here. So I'm going to do 180 minus 77, and that is going to give me RS, which is 103 degrees. PRQ, well, I know I've got a diameter here, right? So I'm just going to add the 28 to it. Diameter is 120 plus 28 gives me 208 degrees. PQ, let's follow these letters. PQR is almost the entire circle except the 77. So for this one, I'm going to do the entire circle minus 77, and I get 283 degrees. There are going to be different methods to get these values, guys, but we should all get the same final answer, but we can approach the problems in different ways. That's okay. And then we've got arc PRS. Notice that is the semicircle, so that's 180 degrees. Okay, let's check out this problem. Find the measures of each arc. Okay, so arc BD. Here's BD. If I notice that this angle is 210, I can figure out this angle, and then I'll be able to determine the arc. So I'm going to do 360 minus 210. That gives me 150 degrees, is arc BD. And then let's look at arc AE. So AE here is still using that same angle. So it's also 150 degrees. So how did that work? How did these two angles, these two arcs, which look different because they're on different circles, right? Here's one circle, here's another circle. These are called concentric circles when they have the same center point. How did that work? They got the same angle, the same arc measure. Congruent circles and arcs. All circles are similar. Two circles, remember, similar means same shape, different size. That's all it means. Different sizes, they're all the same shape though, that's for sure, right? Two circles are congruent if they have the same radius. Remember, congruent means everything's the same about them. Two arcs are congruent if they have the same measure and are in the same circle or congruent circles. Okay? It is possible for two arcs to be the same measure but not congruent, and that's what happened to this one of these two above. Same measure but not congruent because different radii. So let's determine whether the arcs below are congruent. So EF, if I look at arc EF, first of all, I want to realize the radius is 4. The central angle here is 75, so that tells me the arc is 75 degrees. The radius of this circle, well, if the diameter is 8, the radius is 4. If the central angle is 75, GH is 75 degrees. So yes, we've got congruent arcs. Same radii, same measure. Okay, STV is right here. We've got the same circle, so we don't need to look at the radius. STV is, here's a 90-degree angle plus 30, gives me 120. And then we're looking at UVT. Here's UVT. It's almost the diameter, right, a semicircle, so I'm going to do 180 minus 30 gives me 150. And they're not congruent because they don't have the same measure. Okay? That is all there is to know about arcs and central angle measures. You guys are going to be doing some practice. Good job.